We've been talking a lot about charges. We've been talking about Coulomb's law of electrostatics, where a charge produces a force on another charge and whatever. There's one more thing we need to know before we can move on to something new, and that's called the superposition principle. Now, I'm just gonna define it. If you already know what this means, the rest of this video is gonna be useless for you because it's fairly simple, but I'm going to tell you a little bit about it in case you don't totally understand what this means or you don't understand vector geometry. So the statement is fairly simple. It says that if you have a charge, right? If you have a charge, that's a charge, and you have two or more charges around it. Now we know if we have one charge, we can find the force on this charge to this charge, right? Using Coulomb's law of electrostatics. What if we have more than one charge? What if we have another charge down there, another charge down there, all at different distances and whatever? The way to find out what the force on this charge would be. So let me just draw what I said. You have a charge here, let's say Q, right? And then you have a charge here, Q1. Let's say that's separated by a distance, whatever, x1. You have another charge, Q2 by x2, whatever. Let's keep it simple and have two charges. We want to find the force on this charge, right? Now, if it was only that, we could just use Coulomb's law of electrostatics. If it was only that, we could use Coulomb's law of electrostatics. So the superposition principle is simply saying the same thing. What it's saying is, if you want to find out the force on that charge Q, you have to find the vector sum. This is the most important term. The vector sum of the forces. So for those of you who already know what vector sum means, you find the force to do that, it's going to be there. You find the force to do that, it's going to be there. You take the vector sum of these two. But for those of you who don't understand what vector sum is, let's just go through it. It's really simple. What is a vector? If you know what a vector is, it's really simple. A vector is any quantity that has magnitude and direction. What that means is, say I'm holding this phone in my hand right now, right? Say I throw it outside. I'm going to throw my phone. Now, what am I doing to throw it? I'm giving it a force, right? Now, this force is going to have some magnitude, whatever. Maybe it might be X Newton, Y Newton, whatever. And I give the force. But I'm giving the force in a certain direction, right? That's why the phone is going to go there. If I give the same amount of force in this direction, the phone is going to go up. If I give it in that direction, it's going to go that side, right? I need my phone back. Alright, so we can easily see that the direction of the applied force is the main cause of where the phone is going to go. It defines the trajectory, right? The direction. So a vector is simply something that has magnitude and direction. So now we know what a vector is. We know now what a vector is. So why is it different vector sum to a regular sum? Well, it's fairly simple if you think about it. If I'm holding this pen right now and the pen's not moving, right? Because I'm not applying any force. If I pull the pen this way, I'm applying certain force to the pen, therefore it's moving. If I take this hand and I pull them with the same force, the pen doesn't move. It doesn't go there, it doesn't go there, it stays there because both these forces are equal. Why? Because the resultant force is staying zero. Meaning, I have a body here, I apply, say, 5 newtons on this side. And then, I apply 5 newtons on this side at the same time. What happens? They are in opposite directions, so the resultant force is 0 newtons. It's fairly simple to think, right? But this is the whole concept. Normally, if it's in opposite directions, we take one of them And by the way, a vector is written like the force. This is force. If you want to say the vector, you just put an arrow on top. That's how you denote a vector. So the way, if in this case, the way we would have solved it, well, we can easily tell that it's going to be 0. But the way we would solve it is, this is in one direction, and this is in the positive x direction. This is in the negative x direction. Where I get this from? The coordinate axis, right? This is x, this is y, the other side is negative x. So the entire sum would be 5 Newton minus 5 Newton. Why? Because this is negative, which is 0. I mean, there are some more rules, because, I mean, what happens if, in this case, see, the force is this way and another force is that way. They're not totally, there's an angle between them. So there are some rules. I don't think we should get into them, because, I mean, we could if you want, but for now, let's just leave it at simple stuff. So, yeah, that's it. That's how vectors work. So back to the question, back to the thing that we were talking about, the superposition principle, right? So let's get this stuff out. We don't need this. We don't need any of that. Alright, whatever. So it says that if you have more than one force acting on a certain body, you have to take the vector sum of them. So if we had, oh, that example was fine. Let's say we have, okay, in a straight line, all right? Say we have, this is the charge we want to find out the force on, Q, all right? Say this is 5 coulombs, this is also 5 coulombs, and they're both separated by an equal distance. Now we know that the force on this is going to be nothing. Why we know that? Because the force on this, do that, let's say all of them were positive, right? Positives repel, right? And it's going to repel in this direction with a force, whatever. And in this direction with the same force. What happens? This is minus, this is plus. The force acting on it is 0. Which means we don't simply add it, we take the vector sum. That's a superposition principle. It's fairly easy, so I'm not elaborating. This was elaborate enough. If you want me to go a little more in it, just write a comment or whatever. And yeah, so that's it. That's the superposition principle. Yeah, pretty much.